Hello everybody, welcome back to Vectorverse Learning. Today we'll be teaching you vectors. So a vector by definition is a value that has both magnitude and direction. So for example, let's list out some vectors and some scalars. So scalar quantities are quantities that only have magnitude, and vector quantities have magnitude and direction. So a scalar would first off be temperature. And another one could be time, as time does not have a direction. Same thing with temperature. Another one could be mass. So anything that just doesn't have a direction really would be listed as a scalar quantity. So now let's move on to vector. So let's say that you were looking at a velocity. A velocity could be this way, it could be that way, it could be this way, it could be that way. So a velocity would be vector. However, speed is the magnitude of velocity. So speed would be in the scalars. And then displacement, you could have a displacement this way, you could have a displacement this way, which all have direction. So displacement. However, distance is the absolute value of displacement. So distance would be a scalar. There are many other vector and scalars, but this just gives you a concept of it. Acceleration would be a vector. Force would be a vector, but we haven't covered that yet. There are a lot of vectors and scalars in physics. Physics is very large. There's a lot to learn. So today I will be using, most of our problems, we will be using velocity and displacement. So first off, let's say that there is a car going this direction. Actually, no. Let's say that you walk a distance this far, a distance of 6 meters, which will be, the vector will be represented by an arrow this in this direction, and then you walk a distance of 5 meters in this direction. So what would be your resulting displacement? Now you may think that since this side is 6 and this side is 5, that displacement would just be 6 plus 5, or sum of the displacements. However, you would be wrong, as we can look at these two vectors a different way, where the sum of these vectors is equal to this resulting vector right here, as you would be going from this point to this point. Also, let's go north, south, east, west. Let's just put this here. It's going to be for every problem, by the way. So our resulting vector, let's say that this is displacement, so we're going to call it d. So we know that by the Pythagorean theorem that d squared plus 5 squared, equals 5 squared plus 6 squared. Then you could take the square root of both sides. So then you get d equals the square root of 36 plus 25. Oops. Which is equal to, what is that, 1, and then 61. The square root of 61 is equal to displacement. So this is our answer, meters. So vector math is much different from normal math, as the direction really does affect our answers a lot. Let's look at another problem. So let's say you are walking and you go 7 meters east. Then you go 3 meters north. Then you go 4 meters east. Then you go 3 meters south. What would be your resulting displacement from the whole time period? So displacement is equal to this right here, this difference in these 2 points. So this would just be equal to 1, 2, 3, 4, 5, 6, 7. Then you go up here, you have 8, 9, 10, 11, and then these two cancel each other out. So you result in the same place. So our displacement, displacement equals 11 meters. So I will give another example. This one will be trig related. Let's say that your displacement is 8, or let's say it's 9 meters. This isn't going to be exact math-wise, or not math-wise, graph-wise with the graphing paper, because it's kind of difficult to map out these problems beforehand. So let's say that your total displacement is 9 meters, and then your displacement in the x direction is 4 meters, which isn't correct with the graph. Just ignore the graph for now. What is your displacement in, what the heck? What is the magnitude of this vector right here? So let's put this into a notation. So we have R, we have our resultant vector, which is the sum of the vectors, is equal to R, or dx, so our x displacement, plus dy squared, and then this is squared too since it's a triangle. So we are currently looking for dy, which is vector. These are all vectors. So we can subtract dx from both sides, and we get r squared minus dx squared equals dy squared. Let's take the square root of both sides, and you get radical 9 meters squared, since that is our r, minus 4 meters squared equals dy vector. So dy equals this right here, which is radical 81 minus 16, which is equal to that's equal to 65. So dy equals radical 65. Now, that's not anything, by the way. If it was 64, that'd be 8, so it's about 8. But it's not really 8. So this has the units meters on the outside of the parentheses. And then since I asked for the displacement in the y direction, you have to say radical 65 meters north. And that is our answer. So I'm going to give you a problem that you can try on your own. And I will go through with you. So let's say you have, let's say you start off at point 0 right here, and you go 6 meters. Oh, that was a bad arrow. 6 meters east, then you go 4 meters north, then you go 3 meters east. What the heck is going on with my vectors? 3 meters east. Imagine it's a straight line. Then you go 2 meters north, and then you go, actually that could be all. It's a good enough problem. What is our resultant vector? Now pause. I'll write the values for you so that way you could see it easier. So this is 6, this is 4, this is 3, this is 2. These are all meters. Find this vector right here, which will be denoted by r. So pause the video and try that out on your own paper right now, and I will go over it now. So let's break this up into 2 mini r's, which are in the same direction. So let's have this as R1, and then this as R2, and then we're gonna note that R1 plus R2 equals R. These are all vectors, and since they're in the same direction, you can just add them all up normally. You don't have to do any vector math, since if you ended up doing that, you would just get the same thing. So for the first part, we have R1 squared equals 4 meters squared plus 6 meters squared. And then we get that is equal to root 16 plus meters squared plus 36 meters squared, which is equal to our r value. R1. So, also the meter is squared, we're not squaring the 16. So that is equal to 5 radical 52 meters, because you square root the meters. That is R1. Now to solve for R2, we have R2. Oops, well, we are going to square it. R2 squared equals 2 squared plus 3 squared. So R2 equals radical 4 plus 9 equals radical 13 meters. These are meters squared as the units. So R equals, we have that our entire R is equal to the sum of these two r's. So r equals radical 52 meters plus radical 13 meters. How did I end up here? that is our answer. For those of you who plug into a calculator, I will plug this all in right now and tell you what this is equal to. This is equal to about 10.89 meters. So if you got something similar to that, then congrats, you got the question right. That is all you need to know for vectors for now. It does not get much more complicated than that in this course. It is relatively easy, I'd say. Probably like the most important thing to know for physics, I would say. I don't think that anything is really more important than understanding vectors. So let me know if you have any questions, comments, concern that I can address in the next video. The next video will be river problems, which is an amazing unit. It's still part of kinematics. It's one of the last parts of kinematics. We just have to do relative velocity after that. And then that's all for 1D kinematics. Actually, those are 2D kinematics. This is the last video for one-dimensional kinematics, and it's not even 1 dimensions. Anyway, I hope everybody enjoyed this video. Leave questions, comments, concerns, and I'll see you in the next one. Thank you for watching. Please like and subscribe.